course with analysis chapter 3, and with chapter 3 we are going to look at sequence, the forms of sequence that we have, the types of sequence that we have, some theory about sequence, limit of sequence, bounded monotonic sequence, and evaluating sequence. So please make sure you watch this video to the end. So we are going to start with sequence. We're going to talk about sequence, right? You know, we have an arrangement of something, a way where something is arranged, right? So it's in a sequence, it's in a way, the same way. That means that it's the same sequence. Like me, I'm having people wearing the same color in the same light. It means that we've been in a sequence, right? Maybe red, blue, green, yellow, and it moves like that. So it's in a sequence like that. So when we talk about a sequence is a set of numbers that is U1, U2, U3 in a definite order of arrangement and formed by a definite rule. So with a sequence, they have rules. So they follow a rule, a certain rule given to them. So with a sequence, they are followed by certain rules, right? And if they are followed by a certain rule, we call them sequence of numbers. Sequence of numbers. Now listen to this. Every number in a sequence is called term of sequence. So with this, it is called term of sequence because it's a number or a member of a sequence. So every number in a sequence is called term of sequence. Now let's move on to the forms of sequence we have. Now note this. If a sequence has a last term, what does it mean? If I talk about having a last term, maybe U1, U2, U3, and it's close. We have another one which is called U1, U2. So, if a sequence has a last term, it is called a finite sequence. This is called a finite sequence because it has a last term. But if a sequence don't have a last term, it is called an infinite sequence. This is a form of sequence we have. So we have the finite sequence and the infinite sequence. Now, the nth term of a sequence is called un. So to find the nth term of a sequence, this is called un. This is the nth term of a sequence, which is called un. Please note that. So we're going to look at some examples and we're going to identify whether this is a finite sequence or infinite sequence. So let's take example. So example, we have 1, which is 1, 2, 3, and 1, 4, 6, 8. Please check, comment this in the comment section. Which of these are finite and infinite? So this is A and this is B. So comment, let's see. Yeah, I know you've commented. So A is an what? Infinite sequence. Why? It's because of this third dot. It's representing that the A doesn't what? End. It continues. But B is a finite sequence because it has what? A last 10. Please note that. Now we are moving on. Now we are moving on to the type of sequence that we have. We have types of sequence. We have 3 types of sequence. Yes, we have 3 types of sequence. So when we talk about the first type of sequence, we call it arithmetic sequence. Arithmetic sequence. And when we talk about arithmetic sequence, now let's see something. Un plus 1 minus un is equal to d. Now, with arithmetic sequence, this is the formula for it. So we're going to the things one by one and identify them. Now, when we talk about un is the first term or the nth term. Un plus 1 is the second term. D is the common difference. It's a constant, which is the common difference. So, now we have something called the sum of arithmetic sequence. And note this formula, which is Sn is equal to n over 2 into bracket 2a plus n minus 1d. The n is the number of 10, a is the first 10, n is the number of 10, and d is the common difference. So we're going to take one example and we'll try solving, finding the sum of the arithmetic sequence. So let's take an example. We have an example which is 2, 8. That is 2, 5, 8, 11. And we are supposed to find the first 10 terms, the sum of 10 terms of this sequence. This is an infinite sequence. So what you do now is you're going to take the formula, which is n over 2. What are you finding? Is like what? 10th term. So that would be S10 is equal to what? 10 over 2. 2 times the first term, this is a, which is 2, plus the 10 minus 1. What's the common difference? Subtract this from this, subtract it from which is 3. So this is it. And at the end, S10 becomes 155. So this is how we find the sum of sequence, the sum of arithmetic sequence. So you should know that. Now let's move on to, now I didn't talk about something. We have series and, or sequence and series, right? With a series, you see this is a sequence, but series, for us to write the series, it's going to be plus. So note this, the series, there's an operation sign in the middle, right? But with the sequence, there's no operation sign in the middle. Now let's move on to the next type of the sequence. The next type is called the geometric sequence. So we have the geometric sequence, which is geometric sequence. And with a geometric sequence, a sequence un is said to be geometric if un plus 1 is equal to r un. And for all n. Note this symbol is for all. It means for all. We have another one which is this. There exists. You should note that. So this symbol is for all and this is there exists. So with this, let's look at something. Now for us to find the sum of the geometric sequence, we have two formulas you need to know. The first formula is Sn is equal to a 1 minus Rn over 1 minus r. This only holds if 1 is greater than r. Note this, if only 1 is greater than r. But I have another one, Sn is equal to a minus Rn minus 1 all over r minus 1. This holds if r is greater than 1. So these are the two formulas for finding the sum of the geometric sequence, right? Now let's look at something. They say a is the first thing, r is the common ratio. So with the r, this r represents the common ratio. That is the r, common ratio. Now let's take on note of something. The C type of the sequence is a sequence which is neither arithmetic or geometric. So with that sequence, it's another form of sequence. You will, as time moves on, you get to know it, which is the limit of a sequence. So we talk about the infinite sequence, right? So an infinite sequence, un, whereby this approaches to this, is said to have a limit of L as n approaches to what? Infinity. If un can be made as closer to L. So what it means is that this is an infinite sequence and it's said to be have a limit of L when n approaches to what? Infinity, right? Now, so for this, you can write like limit as n approaches to infinity, un is equal to 1. Now, we should note this. Before we move on, we have something. Note, if a sequence has a limit, it is called a convergent sequence. And if a sequence has no limit, it is called divergent sequence. Please take note of that. So we have some examples that we need to know. And first example is that plus 1n has a limit of 1. Why? we'll get to know that. So this has a limit of 1, and with this, n squared plus 1 all over n has no limit. So with this is a convergent sequence, and this is what a divergent sequence. Now, we're moving on to the how to solve evaluating limits. So we'll get to know how this limit is 1 and not. Now, we have some theorems of sequence. Check the terms of sequence on the screen and make sure you go through them very well. With these sequences, they're very important and you need to know all these rules, right? Yes. The next topic we are moving on is the bounded monotonic sequence. A bounded monotonic sequence. Bounded monotonic sequence. Now, when we talk about bounded monotonic sequence, a sequence UN is said to be bounded above if there exists n, which is a constant. So we have capital N and small n. This is the upper bound. This is the upper bound, and this we call it lower bound. So with the bounded, we have the upper bound and the lower bound, right? So such that, so with the upper bound, there's a rule that the UN is less than or equal to the capital N. So this is the upper bound and the lower bound. So with any monotonic, when we talk about monotonic, it's increase. We have increasing order. So it is, if it's increasing, it can be called like monotonic increasing order or monotonic non-decreasing order. And if it's decreasing, it's monotonic decreasing order and monotonic non-increasing order. Now when we talk about monotonic, it follows a sequence. So 1, 2, 3 is what? A monotonic increasing order, which is a monotonic non-decreasing order. So you need to know the type, right? Yes. So let's take an example. So we have this question given to us, which is 2n plus 1 all over n. We are asked to say that this sequence is bounded. Now, why is this sequence bounded? Now, for us to know whether it is an increasing monotonic sequence or a decreasing monotonic sequence, you need to put your numbers inside. So you can start from number 1, 2, 3, and when you put inside, you know, take a calculator. Let's see something here. Now, when you take a calculator and put 2 into bracket 1 plus 1 all over 1, you see that the first thing it will give you is 3. So the 3 is the first step when you use 1. That means that 3 becomes what? The upper bound. The upper bound. So the 3 becomes the upper bound. For you to find the lower bound, you see, you're going to take an infinite number. Mostly I use 100. So take this, do it 2 into bracket 100 plus 1 all over 100. You look at the number will be approaching to something. The number will be approaching to a certain number, and that number is what? 2. So 2 becomes the lower bound. So whenever they ask you to prove it, for you to prove it, you can put numbers inside one by one to know this is a monotonic decreasing sequence or monotonic non-increasing sequence. So because it's moving from 3 to 1. So for you to know the lower bound and upper bound, with the upper bound you put in 1, and with the lower bound you're going to put in what? An infinite number. Being 100 or 1,000, you know that you'll be approaching to something, and you'll be approaching to a certain number, and that number becomes the lower bound. So let's move on. So therefore, you know that the upper bound is 3 and the lower bound is 2. Now, take this n plus 1 all over n. And please, let's check. Confirm that whether this is a monotonic decreasing order, and also find the upper bound of this and the lower bound of this. Comment in the comment section. Yes. So we are moving on. Now we've gotten to evaluation of limit of sequence. So with evaluating of limit of sequence, we need to know something. We have 3 rules that you must follow. Now, these 3 methods, there are 3 methods, sorry. I'm going to teach you all the 3 methods for you to find the limit of a sequence. So the first method is called Fibonacci sequence method, and the second one is called L'Hopital. And the third one, what you need to do is your calculator. So let's see that. So now we're going to take a question and I'll teach you the three. So you're going to use the Fibonacci, this one. So let's take a question like this. So limit n plus n all over n plus 1. And as n approaches infinity. We are supposed to find the limit n over n plus 1 as n approaches infinity. Now I'm going to use the Fibonacci one. But the Fibonacci, what to do is that you are going to factorize the highest exponent of n. Now the highest exponent of n is n. So you are going to write n over n. So you are going to factorize it down in the top. You open your bracket. Now when you factorize the n out, what is left here? We have 1 here, closed. When you factorize this n out, you have what? 1. But it means that when you multiply this by this, you are going to get n plus. When you multiply this by this, you should get what? 1. It means you are going to get 1 over n. So I've been able to factorize it out, factorize the top and factorize it down. Now I'm going to put in infinity. Now note this. You see this one? It's going to cancel, leaving this. So when you put infinity inside, you're going to get 1 over 1 plus 1 over infinity. Because they're saying that n approaches to what? Infinity. And this return to 0. You should know that 1 over infinity is 0. Therefore the answer is 1. So the limit of this is 1 using the Fibonacci one. Now let me choose you. Note, first you're going to factorize n with the highest exponent. N with the highest exponent is n. So n over, we'll look at it's n. Then when you factorize it, this time is going to give you this. So we get 1 here. This time will give you n. This time will give you n. Now we are taking the limit as n approaches to infinity. So we are going to put infinite inside. 1 over infinity is 0. Therefore 1 over 1 gives you 1. So the limit of this is 1. This is the Fibonacci one. Now also you can use your calculator to verify that. Let's see something. Take your calculator, right? Now, you want us to find the limit. Take your calculator. And let's take a huge value of n. Let's use n to be 100. So 100 over 100 plus 1. You know that it is approaching to what? A certain number. That's 0.999. It means that 0.999, approximately it is 1. So this is the way using calculator. You take a huge number of n and you put it inside. Now, in certain cases, some of them doesn't work. So some, you need to use the Fibonacci or the L'Hopital. I'm going to teach you the L'Hopital, right? Now, let's take another question, right, to solve and see. Now, so we did one that, we did one from the previous one. We had that n plus 1 over n has a limit of 1. This has a limit of 1. Let's see. Let's factorize it out. So this will be n over n. This will be 1 plus 1 over infinity and 1. They give you 0, so the limit is 1. But we talk about another one which has no limit, right? From it, so we say that n squared plus 1 all over n has no limit. Let's see. Now, which one is the highest number? It is n squared, so n squared over n squared. You open your bracket. This will give you 1 plus, this will give you 1 over n squared all over. This will give you 1 over n. Because when you multiply this by this, it's going to give you n. And when you multiply this by, it's going to give you n squared. When you multiply this by, it's going to give you 1. Note, when you put n being equal to infinite, this will cancel this. So when you put n being equal to infinity, you have 1 plus 1 over infinity squared all over 1 over infinity. And this gives you 0. So this has no limit, but this will make it what? Undefined. So the limit is not there. So this sequence what? Diverges, right? Because there's no limit. So from the previous one we did, as we said that there's no limit. This is true because when you solve it, it has no what? Limit. Okay, let's take another one. With the next one, we're going to take 4 minus 2n minus 3n squared all over 4n squared plus 5n. And we are finding the limit of this. Now, as n approaches to infinity, so let's use the highest exponent is n squared. So n squared over n squared, bracket open. This will give you 4. This will give you 4 over n squared minus 2 over n minus 3. And all over, this will give you 4. We go 4 plus 5 over n. Wherever there's over n, it tends to 0. So this tends to 0, this tends to 0, this tends to 0. Therefore, the limit becomes negative 3 over 4. As simple as that. So we just, this will cancel this. This is called the factorization end, right? Or you can use a calculator, as I said. You can use a calculator to take a huge number, and this number will be approaching to something. And you like to be approaching to negative 0.747. 747, approximately negative 0.75, and this is it, right? Yes. Now, the next method I'm going to teach you is the using differentiation. Though you have no idea about differentiation, but that is called the L'Hopital rule. That means you're going to differentiate the top and differentiate the down, and after you put in your value. Now let's do something. Differentiation is let me give you a brief about differentiation. This is the normal differentiation I'm talking about. So for example, if I have x squared, or if I have x is equal to n, for me to differentiate it, you're going to put the n in front, and that will be x n minus 1. This is the rule for differentiation, right? So for here, let's differentiate it. This is having an exponent of 1. So when you differentiate it, you're going to get 1, right? Because this will give you n minus 1, and you bring the 1 inside, and this will be n exponent 0, which is equal to 1. That's any number exponent 0 is 1. Now let's differentiate 1. When you differentiate the quantity, it becomes 0, so you have 0 here. All over. When you differentiate this, you get what? 1. So the limit is 1. So this is the L'Hopital rule. You differentiate the top, you differentiate the down, and put in your values inside. As simple as that. So you can use the L'Hopital rule, the Fibonacci rule, or you can use the calculator. That's very simple to solve for limit or limit. Yes. So thank you very much for watching this video, and I hope you love this video. Kindly subscribe to my YouTube channel. Thank you.